In this exercise, we're going to look at this reaction where 2 moles of SO3 gas are in equilibrium with 2 moles of SO2 gas and 1 mole of oxygen gas. And for this equilibrium, the value of the K sub P is 0.338 at a temperature of 1000 Kelvin. If this container has these given pressures for the gases, we need to find out, is this system at equilibrium already? And if it's not at equilibrium, which direction will the reaction shift in order to reach equilibrium? In order to do this, we're first going to have to write the Kp expression, because remember, that Kp expression is what we will use to calculate Q. So we'll find the Kp expression, we'll plug in the values for the current pressures to find the reaction quotient Q, and then we'll compare the equilibrium constant to the reaction quotient to help us determine, is this reaction at equilibrium, and if not, which way will it shift? So let's go ahead and get started. First, let's write the equilibrium constant expression. In this case, Kp is going to equal the pressures of the SO2 gas raised to the second power, because we have that coefficient of 2, multiplied by the partial pressure of the oxygen gas raised to the first power, because it has a coefficient of 1. In the denominator, we'll have the partial pressure of SO3 gas, again raised to the second power, because we have the coefficient of 2 in the equilibrium equation. Now that we have the equilibrium constant expression, we'll use this expression together with the given concentrations or pressures to find what the current value for Q is. So let's go ahead and calculate Q. So the partial pressure for SO2 currently is 0.41 atmospheres. And we'll square that. The pressure for O2 gas is given as 2.5 atmospheres. And the pressure for SO3 gas is given as 0.16 atmospheres. And don't forget, we need to square that because we have a coefficient of 2 for SO3. Now when you plug those numbers into your calculator, what you'll find is that Q has a value of about 16. So now we come to this step number 3. We need to compare K and Q. So K, which we see is 0.338, and Q, which is 16. So which one is greater? We see that 16 is greater than 0.338. So which direction will the reaction shift? The reaction will shift to the left in order to reach equilibrium. So that means that we have too much of the products, so we want to use up some of the products and form more of the SO3 gas in order to reach equilibrium.